Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into something profoundly familiar, yet quietly mysterious, the story of oxygen in your body. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into oxygen together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here quietly unfolding the story. Take a slow, easy breath. Let it out gently, and just like that, you're participating in something ancient, something cosmic. Oxygen might seem like just another part of your daily routine, something you hardly think about, something you can't see, but each inhale is the end of a journey that began in the heart of a dying star. Yes, truly, the oxygen in your lungs right now was forged in the immense heat and pressure of a supernova billions of years ago. A massive star reached the end of its life, collapsed and exploded, flinging its elements into the vastness of space. Among them was oxygen, one of the building blocks of life as we know it. Those stardust atoms floated, cooled, drifted. Some joined clouds of gas and dust that would become solar systems. One such cloud formed a small yellow star and a few rocky planets orbiting it. One of those planets was Earth. Your home, your breath's destination. It's hard to grasp, isn't it? That with every inhale you're drawing in particles born in fear and scattered across time. And yet, here they are, whispering through your nose, sliding into your lungs, crossing invisible barriers, and slipping quietly into your blood, all without you needing to lift a finger. And as quietly as they arrived, they begin their work, helping you blink, helping you think, helping you sleep. Oxygen doesn't just keep you alive, it keeps you going. But tonight we won't rush, we won't get lost in the technical names or tangled diagrams, at least not in a way that feels overwhelming. Instead, we'll float gently through the story, from the moment oxygen brushes your nostrils to the intricate ballet of molecules in your blood, from the red cells that carry it to the tissues that quietly absorb it, to the cells that transform it into energy, and eventually we'll follow it back again, out into the air, to be used by another creature, in another moment, under another sky. There's something humbling about that, something beautifully, ordinary and quietly profound, because oxygen isn't yours really. It doesn't belong to you, it visits, it helps, and then it moves on, and while it's here, it makes almost everything possible. You'll find it in every laugh, every tear, every step, every dream. It's in the cells of your fingertips and the thoughts of your brain. It's in your memories, your voice, and even in the warmth of your skin. So tonight, we'll trace the journey. Not in a loud, dramatic way, but slowly. As if we're watching a single breath in slow motion. From the stars, to the air, to your chest. And maybe, by the end, you'll feel that next breath just a little differently. Not as a background process, not as a biological reflex, but as something graceful and connected. A thread tying you to the cosmos. You are, after all, breathing stardust. But stardust that listens, that learns, that dreams. So wherever you are, curled under blankets, listening on a night walk, drifting off in the soft hush of evening, know this: oxygen is already at work. It's already in you, and it has been since the day you were born. Let's follow its story together. Take another slow breath in. There it is again, air, invisible, weightless, effortless. It surrounds you always, pressing gently against your skin, slipping in and out of your lungs with barely a whisper. You rarely think about what it's made of unless something smells strange or a breeze carries a hint of spring. But the air is more than a simple backdrop. It's a cocktail of elements, a carefully balanced mixture that allows life as we know it to exist. So what exactly are you breathing in? About 78% of the air you just inhaled is nitrogen. Quiet, unassuming nitrogen. It doesn't react much, doesn't get a lot of credit, but it's always there like the silent friend at a dinner party who holds the space together. Then roughly 21% is oxygen. That's the star of tonight's story, the one your body craves and uses with almost every cell. The rest? Just slivers. Argon, carbon dioxide, neon, helium, hydrogen, even trace amounts of ozone and methane. Tiny ingredients in this gaseous recipe. But oxygen, that 21%, that's what changes everything. That's the part your lungs notice. That's the part your cells need. You might wonder, why not more? Why isn't the air richer in oxygen if it's so essential? Well, it wasn't always this way. Billions of years ago, Earth's early atmosphere was almost entirely devoid of oxygen. It was only after tiny cyanobacteria began releasing it through photosynthesis that oxygen levels slowly crept up. Eventually the air became breathable, but not too breathable. See, if oxygen were much more concentrated, fires would burn too easily. Metal would rust faster. Even your own cells could suffer damage from something called oxidative stress. So 21%, that's just about right. Enough to fuel life, not so much to harm it. Now, this balance isn't always the same everywhere. The air you breathe in a forest feels different than the air beside a highway. And it is. Oxygen content might stay at about the same, but the feel of the air, its humidity, temperature, scent and pollutants, can change how your body experiences it. Take a deep breath in a pine forest. You might notice the scent of trees, a certain sharpness in your nose, a clarity that feels almost medicinal. That's partly due to compounds called phytoncides, tiny plant emissions that can calm your nervous system. The air feels cleaner not just because it smells nice, but because trees are helping filter particulates and produce just a little more of that precious oxygen. Now imagine standing high in the mountains. The air is crisp, thinner. It feels harder to breathe, even though oxygen still makes up 21% of the atmosphere there too. The trick is, the pressure is lower. Fewer oxygen molecules are entering your lungs with each breath. Your body notices. It responds. Your breathing becomes faster. Your heart works harder. If you stay long enough, your body will start producing more red blood cells to help carry what oxygen it can find. And in the city, well, urban air is a little more complex. Alongside oxygen and nitrogen are pollutants, car exhaust dust, ozone from cars and sunlight reacting together. On some days, you can see the difference in a brownish haze. On others, you can feel it as a scratch in your throat or a tightness in your chest. Your body has its ways of protecting you, tiny hairs in your nose, mucus in your airways, but it still notices the difference. Breathing becomes not just a physical act, but a conversation between your body and the world around you. And seasons matter too. In winter, cold air is drier. Your nostrils may sting, your breath might look like a cloud. Your lungs warm and humidify each. Inhale, doing the quiet work of making cold air safe to use. In spring, the air carries pollen, stirring sneezes and sniffles. In summer, the heat can hold smog close to the ground. And in autumn, the cool, crisp air often feels like the easiest to breathe, a quiet invitation to fill your lungs and relax. Even indoors, air has its personality. A freshly cleaned room might carry the scent of lemon or lavender. A library has that soft, papery stillness. A warm kitchen smells like spices and heat and home. You breathe all of this in, oxygen riding silently among the aromas. And yet, with every inhale, your body filters all the extras and gently extracts what it needs. The oxygen slips in, ready to begin its work. You don't need to think about it. You don't need to ask. Your body just does it. There's something beautiful in that, in the simplicity, in the quiet loyalty of a system that keeps you alive without ever demanding your attention. The air has always been there, waiting, surrounding you like an invisible ocean, and every breath you take is a reminder that you're still here, still part of the atmosphere, still connected to every tree, every ocean wave, every person breathing nearby. Because the air isn't just yours, it's shared, recycled. The oxygen you inhale tonight might have once passed through the leaves of an Amazon tree, the lungs of a blue whale, or the breath of someone you've never met across the globe. So tonight, as we begin this gentle exploration of oxygen's journey, let yourself settle into that thought. This breath is not just biology, it's participation, it's connection, it's the beginning of a story that continues quietly, invisibly, with every breath you take. You breathe more than 20,000 times a day, and yet most of those breaths happen quietly, unnoticed, automatic. You rarely stop to consider the architecture that makes each one possible, the winding halls and softly moving doors that usher the air in, warm it gently, and guide it to the deep, spongy chambers where the real exchange takes place. Let's take a quiet tour. Start at the nose, if you'd like. It's not just a protrusion on your face or a place to bounce glasses. It's the grand front entrance to your respiratory system. As air slips in through your nostrils, it enters a passageway lined with tiny hairs called vibrissae. These aren't for decoration. They were your first line of defense. Dust, pollen, even stray insects. Many are stopped here before they can go deeper. But the air doesn't stop. It flows inward into the nasal cavity where something magical begins. Warming, moistening and filtering. The inner lining of your nasal passages is covered in mucus and a microscopic forest of cilia. Tiny hair-like structures that wave rhythmically. Together, they act like a conveyor belt, trapping unwelcome particles and moving them gently toward the throat where they can be swallowed or coughed away. Imagine walking through a long hallway in winter, and instead of being met by a blast of cold air, you feel the warmth of a fireplace at the end. That's what your nose is doing with every inhale, taking the chill off the outside air before it reaches the delicate tissue of your lungs. From there, the air drifts down through the pharynx and into the larynx, the voice box. It passes over your vocal cords, which are relaxed and open during quiet breathing, allowing air to pass silently. But they're always ready to vibrate with sound if you speak, hum, or sing, breathing and voice forever intertwined. Now the path narrows. The air enters the trachea or windpipe, a sturdy tube held open by C-shaped rings of cartilage. These rings prevent it from collapsing even as you bend or lie down. Think of it like a flexible hallway with invisible scaffolding, guiding air smoothly downward without obstruction. But this hallway doesn't go straight. It branches. At the base of the trachea, the passage splits into two tubes, the bronchi, each leading to one lung. The right bronchus enters the right lung, the left the left. And from there, the branching continues again and again, like a tree flipping itself upside down inside your chest. Each bronchus divides into bronchioles, smaller and smaller airways that fan out thousands upon thousands, until the air is no longer in a tube but entering something that feels more like a forest canopy. That's the beauty of it. The deeper you go, the softer the journey becomes. Along the way, the same mucus and cilia continue their quiet work, always cleaning, always moving. This self-cleaning system is especially impressive when you consider what it's filtering. Smoke, dust, bacteria, perfume, city air, the scent of toast. It welcomes the oxygen and gently ushers out the rest. By the time the air reaches the smallest bronchioles, it's warm, humidified, and mostly clean. And now, at the very end of this gentle labyrinth, we arrive at the threshold of something extraordinary, the alveoli. But let's not go there just yet. Let's pause for a moment and consider how beautifully all of this is structured. Each part of your airway has a job, not just functionally, but rhythmically. The nose decides what to let in, the trachea guides, the bronchi divide, the bronchioles slow everything down, preparing for something quiet, something crucial. And all of it works with the rhythm of your breath, like a soft bellows. That's an old metaphor, but a good one. In blacksmith shops, Her bellows would gently inflate and contract, pushing air into flames, feeding the fire. Your lungs are like that, in a way, except the fire isn't in your chest. It's in your cells. The breath you just took is already on its way to fuel countless tiny chemical reactions that will keep you warm, awake, healing, thinking. And it all began with a puff of air entering your nose. Even now, as you lie still, you can feel it rising and falling, cool in and warm out. The soft swell of your ribs, the barely noticeable movement of your chest. All of it choreographed, seamless and silent. You don't need to remind your body to do this, it remembers. And not just for you. Every mammal, bird, reptile, even the quiet sleeping dog at your feet, all of them have their own version of this architecture. Evolution may have sculpted it differently across species, but the principle remains: bring the outside in, gently, efficiently and safely. There's something comforting in that, something universal, this hallway of air, this branching tree inside your chest. It's not just yours, it's part of a shared design, a quiet inheritance from millions of years of breathers who came before you. And now, that breath is reaching its final corridor. Next, we'll step gently into the alveoli, those tiny delicate rooms where oxygen finally meets the blood. But for now, just rest in this moment. Feel the quiet architecture inside you steady and true. Every breath a whisper through halls made of tissue and time. Let's go smaller now. Much smaller. By the time a single breath of air has wandered through the maze of bronchi and bronchioles, it's slowed down, softened, and warmed. It has passed bony ridges, muscular tubes, and microscopic gates. And now it arrives at a place so delicate, so quiet, that even most of the noise of biology seems to pause here. The alveoli. There are about 480 million of these tiny air sacs in your lungs. You heard that right. Almost 500 million. Each one no bigger than the tip of a pin. And yet, they are the heart of your breath's purpose. They are the destination. Picture them like little soap bubbles clustered together, fragile, round, and thin-walled. Or perhaps imagine a field of dewdrops before sunrise, each one holding a small reflection of the sky. The alveoli are like that, numerous, translucent, and impossibly light. But don't let their softness fool you. They are marvels of design. Each alveolus is surrounded by a mesh of capillaries, tiny blood vessels so narrow that red blood cells must pass through in single file, like guests at an exclusive event. This is where the handoff happens, where air becomes breath, where the outside becomes part of you. Oxygen in the alveolus doesn't need to be pushed or pumped, it simply drifts, it diffuses, and that's the miracle. Diffusion is the quiet equalizer. It moves molecules from where they're abundant to where they're not, like tea steeping into water or the scent of warm bread filling a kitchen. Oxygen, abundant in the alveoli, slips across the ultra-thin membrane into the blood, where there's less of it. No fanfare, no machinery, just a natural flow, driven by concentration and pressure. The membrane between air and blood is unimaginably thin, just about 0.2 micrometers. That's roughly 1,000 times thinner than a strand of your hair. It's like two worlds touching at the edge of a breath. On one side, oxygen-rich air. On the other, deoxygenated blood, tired from its journey through the body and eager for renewal. At this boundary, gas exchange happens. Oxygen crosses from alveolus into blood. Carbon dioxide produced by your cells travels the other way, leaving the blood and entering the airspace of the alveoli to be exhaled with your next breath. One arrives, one departs. It's like a gentle handshake of life's two most essential gases. It's easy to forget just how fast this is. Each red blood cell only lingers by an alveolus for less than a second. Yet in that blink, oxygen binds to hemoglobin with astonishing precision. And then, like a courier freshly stocked with parcels, the cell moves on, rushing off to make its deliveries. The surface area of all your alveoli combined is around 70 square meters. That's roughly the size of a tennis court, all folded and packed into your chest. Not bad for a couple of lungs. It means there's room for millions of exchanges to happen at once. Each breath refreshes that court. Each exhale clears it, over and over again. And remember, this isn't something you control. You can't direct air into specific alveoli. You don't choose where oxygen lands. The body just knows. It adjusts quietly, balancing pressure, adjusting blood flow, fine-tuning which alveoli are most active at any moment. If some are compressed, for example, if you're lying on your side, others step in, expanding to take in more air. Your lungs are adaptable, responsive and quietly intelligent. Of course, things can go wrong. Alveoli can fill with fluid in pneumonia. They can collapse in certain lung conditions. They can become inflamed or thickened, making gas exchange harder. Smoking can damage their walls, reducing the total surface area for oxygen to cross. But even then, the body tries. It compensates. It reroutes. It does what it can to preserve this most vital of exchanges. And yet when things are working well, you don't feel them at all. You might take a slow breath as you're drifting to sleep, unaware that thousands of oxygen molecules are slipping silently from air into blood, from breath into body. And that, perhaps, is the greatest miracle. That something so essential could be so quiet. No gears turning, no switches flipping, just molecules drifting through membranes, cells passing like shadows through capillaries, and a breath, yours, becoming part of you. So next time you exhale, take a moment to imagine the journey your last breath took. From the air around you, into the branches of your lungs, down to the smallest bronchiole, and finally into the soft, round alveoli. There, like a guest welcomed into a tiny sunlit room, oxygen waited just long enough to be invited in. And now it's on its way to your heart, but we'll follow that path next. Imagine a quiet station at dawn. The air is cool, the sun hasn't quite risen, and just arriving at the platform, almost invisible in its stillness, is oxygen. It's waited patiently, drifting through passages, filtering through tissue, pausing briefly at the alveolar threshold. And now the train has arrived. The red blood cell. You've likely seen a diagram of it before, disc-shaped, soft, with a dip in the middle like a jelly-filled donut with no jelly. But don't let the simplicity fool you. Each red blood cell is a specialist. A silent, dedicated courier designed to carry oxygen. Nothing more, nothing less. Inside each one is a molecule called hemoglobin, and this is where the real meeting happens. Hemoglobin is made of 4 protein subunits, each containing an iron atom nestled inside a structure called a heme group. This iron is the key. When oxygen floats close enough, it binds to the iron, clicking into place like a puzzle piece. No sparks, no fuss, just quiet chemistry. One hemoglobin molecule can carry 4 oxygen molecules. One red blood cell contains about 250 million hemoglobin molecules. And with millions of red blood cells circulating in your body at any moment, the scale becomes quietly staggering. This isn't just transport, it's a coordinated ballet, a molecular embrace. But what's especially elegant is how hemoglobin knows when to bind oxygen and when to let go. In the alveoli, where oxygen concentration is high and conditions are just right, hemoglobin binds oxygen readily. The first molecule binds slowly, but each one after that binds more easily. It's a kind of cooperative behaviour. Oxygen encourages more oxygen. Like one person starting to clap and soon the whole room joins in. But this is chemistry, not concert applause. It's called the oxygen-hemoglobin dissociation curve, and while the name is long, the idea is simple. Hemoglobin adapts. It holds oxygen when it's needed, and it releases it when it's time. As the red blood cell leaves the lung and enters the arteries, it's fully loaded. Bright red now, thanks to the way oxygen alters hemoglobin's shape and colour. That's what gives oxygenated blood its vivid hue. It's not just symbolic, it's real. A colour that marks readiness. And now it begins the second half of its journey. But before we follow it further, let's stay here for a moment. At the site of that first meeting. Because something extraordinary is happening. Oxygen, a gas born in stars, now rests inside your blood. It's no longer just floating. It's been taken in, trusted, carried with care, and all of it happens silently. You don't feel oxygen binding to hemoglobin. You don't hear the red blood cells passing through your capillaries. You don't sense the millions of exchanges occurring in your lungs each minute. But they happen, breath after breath, heartbeat after heartbeat. In fact, if we could shrink ourselves down to the scale of a single alveolus, we'd see a kind of glowing ballet, red blood cells flowing past, each taking on their small cargo, some moving faster, some pausing just long enough. Carbon dioxide, their previous passenger, is left behind, slipping back into the alveoli to be exhaled. And oxygen, light, abundant, purposeful, takes its place. Then off they go. There's a beautiful irony here. Red blood cells don't use the oxygen they carry. They have no mitochondria, no need for respiration. They exist solely to serve. They pick up their cargo, carry it faithfully, deliver it, and return for more, over and over again. For about 120 days. Then they are retired, gently broken down by the liver and spleen, their components recycled to make new cells, new couriers. They are, in a way, the monks of your bloodstream, simple, purposeful, and entirely devoted to the task at hand. And what a task it is. Because oxygen isn't just helping you stay alive, it's helping you live. With each molecule loaded into a red blood cell, your body prepares to power thought, motion, memory, and healing. From this moment in the lungs to the very tips of your fingers, oxygen travels as both guest and gift, but none of it would be possible without hemoglobin. Interestingly, hemoglobin has some rivals. Certain gases combine to its iron more tightly than oxygen. Carbon monoxide, for example, fits so snugly into the hemoglobin molecule that it won't let go, pushing oxygen aside and staying put. That's why carbon monoxide poisoning is so dangerous. It's like having seats on a train permanently reserved by the wrong passenger. Quiet, invisible sabotage. But in normal life, with clean air and healthy lungs, oxygen gets its rightful place. And hemoglobin carries it faithfully. So next time you take a breath, imagine this quiet loading dock inside your lungs. Picture a vast sea of red blood cells arriving, waiting, and leaving. No delays, no arguments, just purpose. Oxygen finds its ride, and the journey continues. Your lungs don't work alone. They may open the door, let the oxygen in, and make the introductions. But from there, it's the heart that takes over. Gentle but persistent, beating more than 100,000 times each day without rest, without complaint. And it all begins with a quiet loop. Let's follow the journey from the moment red blood cells finish loading their precious cargo in the alveoli. They're full now, brightened with oxygen, like tiny lanterns glowing red as they leave the lungs. But before they can nourish your body, they have to pass through one final checkpoint, the right side of your heart. It might sound strange at first. Why would oxygen-rich blood visit the heart again after already entering the lungs? The answer is that the pulmonary loop is a gentle cycle, a sort of handshake between two systems, breath and blood, lungs and heart. But to understand it fully, we need to go just one moment further back. Before red blood cells reach the alveoli, they are carrying the opposite of oxygen, carbon dioxide. They've returned from the body's tissues weary and blue, not in a poetic sense, but literally. Deoxygenated blood appears darker, almost purplish blue in colour, because of the shape hemoglobin takes when oxygen is absent. These cells are ready for renewal. This tired, oxygen-poor blood enters the heart's right atrium, the first of 4 chambers. The atrium receives it from 2 major veins, the superior and inferior vena cava, collecting blood from the entire body. From there it flows down into the right ventricle, which is a bit like a muscular pocket ready to pump. And that pump matters. With each beat, the right ventricle sends the blood through the pulmonary arteries, unique among arteries, because they carry deoxygenated blood. These arteries branch out, divide, and guide the blood toward the lungs, where it will visit the alveoli, bind with oxygen, and begin to glow again. And then, just as quietly, it returns. Newly oxygenated, bright and ready, the blood flows back to the heart through the pulmonary veins, unique among sort of veins because they carry oxygen-rich blood. These veins carry it not into the right side of the heart, but the left atrium, where the next part of the journey begins. But let's pause here, just for a moment. Let's feel the rhythm. Thump, thump. The heart doesn't make decisions. It doesn't wonder who needs oxygen next or worry about where the red blood cells have been. It simply keeps time. It beats in steady pairs. Atrium, then ventricle, right side to lungs, left side to body, over and over again. Even now, as you listen to these words, your heart is keeping pace. Maybe a little slower if you're resting. Maybe a little quicker if you've been moving. But always there, always quiet, a rhythm older than your thoughts, a beat that began before you were born and will continue until the very end. It's not loud. It doesn't need to be. The pulmonary loop is gentle, efficient and beautifully coordinated. It's the system that keeps your lungs from being just balloons. It turns breath into circulation. There's something elegant about the right side of your heart. It doesn't push hard. It doesn't need to. The lungs are close by and the vessels are low pressure, soft-walled and accepting. The job isn't force, it's flow. And just like that, the blood changes colour. Not symbolically, not metaphorically, but visibly. The transition from deoxygenated blue to oxygenated red marks the turning point in the loop. It's like flipping a switch or watching a dim lantern flicker to life. The blood is refreshed, renewed, and ready for something much greater. From here, it's off to the body. But we'll take that step in our next session. For now, just rest in the loop. The pulmonary circuit. Right atrium, right ventricle, lungs. Back to the left atrium. A circle of renewal, a rhythm that never stops. Your lungs may gather the air, but it is your heart that gives it purpose. The blood is full now, brighter, richer, tinged with a soft crimson warmth. Oxygen has found its ride nestled into hemoglobin's open arms, carried along quietly by red blood cells flowing back from the lungs. They arrive not in chaos, but in harmony, calm, purposeful, as if returning from a peaceful ceremony with something sacred to share. And waiting to receive them is the left atrium. The heart has 4 chambers, but the left side, now ready to act, is the more muscular of the two. It handles the heavy lifting. If the right side is the quiet usher guiding blood to the lungs, the left is the great conductor, preparing the grand departure. From the left atrium, the blood passes into the left ventricle, the strongest chamber of the heart. Its walls are thick, dense with cardiac muscle, capable of sending blood not just across a short loop, but through miles of vessels that stretch from the crown of your head to the soles of your feet. This is the moment. The blood waits for the signal, for the next contraction. And when it comes, when the ventricle tightens, it sends the blood soaring out through the aorta, the body's largest artery. The opening of the aortic valve is like the lifting of a curtain, the beginning of the show. From here, the oxygen-rich blood is launched into a vast branching network of vessels, an arterial highway reaching out to every organ, every limb, every corner of you. And it all happens with a single beat. Feel your pulse on your wrist if you'd like. That subtle thump is a wave of pressure created by your left ventricle's push. It's not just a rhythm, it's movement. Each pulse is a new delivery, a new surge of oxygen sent on its way. Blood pressure, the gentle force behind it all, isn't constant. It rises and falls with each beat. But your vessels are elastic. They stretch to accommodate the wave and then rebound, keeping the blood moving forward, even in the quiet moments between contractions. It's not brute force, it's a kind of vascular choreography. And the route that blood takes, it's stunning in its detail. First, the aorta rises, forming an arch above the heart. From that arch branch, arteries that feed the head, brain and arms. The carotid arteries, winding up your neck, deliver oxygen to your thoughts, your words, your memories. The subclavian arteries, tucked under your collarbones, bring breath to the hands you use to write, lift, comfort. Then the aorta curves down behind the heart, descending through the chest and abdomen, sending off vessels to your lungs, your liver, your stomach, kidneys, intestines. and farther still to your legs, your feet. Even your toes receive oxygen with each beat. There's no place too small, no corner too far. Every cell in your body needs oxygen, and the heart knows the way. It's easy to imagine this process as fast and mechanical, but in reality, it's quiet, rhythmic, almost ceremonial. Blood moves in pulses, in waves always, forward. It never pauses, it doesn't hesitate. The entire cardiovascular system is built around one elegant goal: delivery. And the oxygen itself, it doesn't interfere, it doesn't get in the way. It simply rides along, held gently by hemoglobin, waiting for the right conditions to let go. Those conditions don't arrive just yet, not in the aorta, or even in the major arteries. At this stage, the blood is still in transit, still making its way. But with every branching vessel, every narrowing into smaller arteries and arterioles, it's getting closer to the true destination, the capillaries, where release can finally begin. But we'll get there soon. For now, let's return to the heart. It's not just a pump, it's a storyteller. With each beat, it continues a narrative that began in the lungs, one that will unfold in the tissues. The heart keeps the rhythm, turning a simple breath into a full-body experience. The left ventricle doesn't know where the oxygen will end up. It doesn't ask. It simply gives everything it has, every time. There's something deeply comforting about that. That this quiet engine inside your chest has never missed a beat on purpose. That from the moment you were born, it has been working on your behalf day and night, in sleep and in sickness, through joy and rest and uncertainty, and all to keep the oxygen moving from lungs to blood, from blood to heart, from heart to everywhere else. So next time you feel your pulse, whether it's in your wrist, your temple, your neck, know that you're feeling a wave of oxygen-rich blood moving outward in search of purpose. It's not just circulation, it's arrival. It's the first step in the body's great delivery, and soon we'll follow that path deeper, into the smallest roads, the capillaries, where oxygen will finally find the places it was always meant to reach. Imagine a tree turned upside down, its thick trunk rooted in your heart and its branches spreading wide through your body. That's your circulatory system. The aorta, sturdy and strong, is the base. From it extend arteries, bold and steady, designed to carry oxygen-rich blood quickly and efficiently. These vessels don't meander. They move with purpose. Each large artery splits into smaller ones, like limbs into twigs, each narrowing, bending, branching again and again. They are not just tubes, they're maps. Quiet, living roads that carry breath where it's needed. As the arteries shrink into arterioles, something curious happens. The speed of the blood slows, the pressure softens, the journey becomes more careful, more deliberate. Like someone walking slowly through a library, knowing they're close to something important. And they are, because at the end of these pathways lie the capillaries, the smallest blood vessels in your body, narrower than a human hair, so thin that red blood cells must squeeze through them single file, bending as they go. This isn't a highway anymore. It's a hallway, a whisper. But it's also the place where the most meaningful exchange occurs. Each capillary lies nestled against the tissues it serves. Whether it's muscle, skin, liver, bone or brain, each one is waiting quietly for oxygen. And the red blood cells know. When they arrive, they sense the change. Here, the oxygen concentration in the surrounding tissue is lower. The pH may be slightly more acidic. The temperature may be warmer. These are signs, invitations. This is where the Bohr effect comes into play, a gentle principle that describes how hemoglobin adjusts its grip on oxygen depending on the environment. In places where cells are working hard, generating more carbon dioxide, heat and acid, hemoglobin loosens its hold. It releases oxygen more easily. It senses the need, and it responds. It's like a delivery driver noticing a porch light turned on and understanding, this house is waiting. And so the oxygen lets go, not with a pop or a spark, but with a sigh. It diffuses out of the red blood cell, slips through the capillary wall and enters the tissue. There it will be taken up by hungry cells, drawn into mitochondria, fed into the chemical reactions that produce energy. But we'll talk more about that in our next session. For now, stay here, in the quiet space of the capillary. This is where breath becomes action. And yet, for all its importance, the capillary is nearly invisible. You won't see it with your eyes, but you might feel its presence, in the warmth of your fingers, in the blush of your cheeks, in the way a cut bleeds just a little before clotting. Capillaries are everywhere, dense in places like your lungs, your brain, your fingertips, and more sparse in others, like cartilage. They're delicate, they're responsive, and they're incredibly efficient. Together, your capillaries form networks so vast that if you laid them all out end to end, they would stretch for more than 60,000 miles, enough to circle the Earth twice and then some. All for one purpose: exchange. And it's not just oxygen being delivered. At the same time that oxygen leaves the blood, carbon dioxide, the byproduct of cellular respiration, slips in. It's dissolved in the plasma, or sometimes converted into bicarbonate for easier transport. The red blood cell, now slightly dimmed, accepts this return package and prepares for the trip back. But let's not rush yet. Let's appreciate the moment. This is a turning point. Every time your heart beats, it sends blood down these narrowing branches, slowing, quieting, until it reaches this near motionless moment, the handoff. It's as if time pauses, and in that pause life happens. Because oxygen is not just something you inhale, it's something you give away. Your body shares it, cell by cell, breath by breath. And when its task is done, when the red blood cells have lightened their load, they begin their return journey, no longer red and bright, but carrying a new message. It's time to let go. We'll follow them soon, but for now, rest here, in the hush of your smallest vessels, the place where movement becomes stillness, where delivery becomes connection, where oxygen at last becomes part of you. Oxygen has arrived. After its long journey, through the lungs, into the blood, past the chambers of the heart, along twisting vessels and down into whisper-thin capillaries, it now enters its final destination, your cells. And not just any part of the cell. Oxygen has a very specific calling, a room at the very heart of the operation, the mitochondrion. You may remember that name from science class, often called the powerhouse of the cell. A phrase that, while perhaps a bit overused in textbooks, isn't wrong. Mitochondria are where your body makes energy, not metaphorical energy, actual chemical energy in the form of ATP, adenosine triphosphate. ATP is the currency your cells spend to do nearly everything. Contract a muscle, fire a nerve, build a protein, think a thought, blink an eye, and oxygen is essential in this economy. Inside the mitochondria, oxygen plays a vital role in a beautiful process called aerobic respiration. Here, glucose, sugar molecules from the food you eat, is broken down step by step, releasing stored energy. But to extract the full value from glucose, your cells need a final ingredient: oxygen. Think of it as lighting a fire. You can stack the wood, arrange the paper, even strike the match. But without air, without oxygen, there's no flame. In the mitochondria, that flame is the electron transport chain, a molecular assembly line where electrons move through a series of proteins. At the end of this chain waits oxygen, ready to receive those spent electrons. When oxygen accepts them, it combines with hydrogen ions to form water. That's the final act of oxygen's mission. A single inhale, transformed into movement, heat, thought, and a little water, quietly produced inside your cells. This process, incredibly efficient, produces around 36 molecules of ATP for every 1 molecule of glucose. Without oxygen, the cell must resort to a less efficient method, anaerobic respiration, which yields far less energy and creates lactic acid as a byproduct. Useful in emergencies, but not sustainable. So oxygen's arrival isn't just helpful, it's essential. It unlocks the full power of your food, allowing every cell to thrive. And while all this is happening at the molecular level, your body feels the difference. After exercise, when your muscles ache and burn, it's often because they've dipped into anaerobic mode, working faster than oxygen can be delivered. As you rest, oxygen returns, clears the lactic acid, and restores balance. It's a quiet healing cell by cell. Even your brain, though only about 2% of your body weight, consumes around 20% of your oxygen supply. Every thought, every memory, every dream relies on that steady stream. When oxygen drops, the brain is the first to notice. That's why fainting, dizziness, or confusion are among the earliest signs of oxygen deprivation. But when oxygen is plentiful, your body hums. Muscles recover. Organs function to move smoothly. Wounds heal. Thoughts flow. And always, after giving its gift, oxygen leaves behind a small return, carbon dioxide. It's the natural byproduct of cellular respiration. After the mitochondria finished using oxygen to help make ATP, carbon atoms from glucose remain. They are bundled up with oxygen into CO2 and released into the surrounding tissue fluid. From there, CO2 diffuses into nearby capillaries and begins its journey home, back to the lungs to be exhaled. But we'll follow that path a little later. For now, stay here, in this moment of quiet exchange. Imagine your body as a city at night. Each cell is a home, softly lit from within. The capillaries are delivery routes, weaving between buildings, and oxygen is the letter slipped through the mail slot. The spark in the kitchen stove, the warmth behind the window pane. You don't need to feel this process to know it's happening. It's in the way you stretch your arms after a deep breath, the warmth of your skin after a brisk walk, the way your thoughts seem clearer after a moment of stillness and air. Your tissues don't celebrate the arrival of oxygen with fanfare, they simply get to work. The gift is received, used, transformed, and passed on. And in that soft alchemy, your body continues, quietly, steadily, breath by breath. The gift has been given. Oxygen arrived quietly, delivered itself into the waiting arms of your cells, and helped power the fires of life, those soft, ongoing blazes that make thought and motion possible. And now, like all journeys, this one begins to turn back. But oxygen doesn't go back the way it came. It leaves behind a messenger. Carbon dioxide, the signature of a job well done. This is where the return path begins. Inside your tissues, carbon dioxide slips out of the cells and into the blood. Some of it dissolves directly into the plasma, but most enters red blood cells, where an enzyme called carbonic anhydrase transforms it into bicarbonate ions. It's a clever form of packaging. Bicarbonate is easier to carry, less acidic, and helps maintain your blood's delicate pH balance. This transformation isn't dramatic. There's no fizz, no bubbling, just a quiet shift, molecule by molecule, as your blood prepares to head home. But now, the road is different. The arteries that brought oxygen were pressurized and thick-walled, built for speed and strength. The return path, your veins, is slower, softer and quieter. These vessels don't push, they guide. And yet your veins face a challenge: gravity. Much of your deoxygenated blood has to travel upward, from legs and feet and abdomen back to the heart. But your heart isn't sucking it up like a straw. Instead, your body relies on a gentle collaboration between muscle movement and venous valves. Picture walking up a gentle hill, one step at a time, using small gates to prevent backsliding. Each time you move, take a step, flex a muscle, shift your weight, those muscles squeeze the nearby veins, nudging blood upward. Inside the veins are one-way valves that open to let blood pass and then close to prevent it from slipping back down. It's like a soft ratchet system, quiet and efficient. Even now, as you sit or lie down, tiny movements, your breath, your fingers twitching, your calves adjusting, help keep this system running. You don't need to think about it. Your body remembers. The veins collect carbon dioxide-laden blood from all across your body and begin to merge. Smaller veins join into larger ones. venules into veins, veins into major trunks, until finally all paths converge at two great vessels, the superior vena cava, bringing blood from your upper body, and the inferior vena cava collecting from below. Both of these vessels deliver their quiet cargo into the right atrium of your heart. This is where the loop prepares to restart. But before we follow that path again, let's linger a little longer in this return phase. It's easy to overlook. Arteries get the glory. They're bright, powerful, surging with oxygen-rich blood. But veins, they're the ones who carry the stories back. The evidence of life lived. The carbon dioxide they carry holds the memory of action, the contraction of a muscle, the firing of a neuron, the healing of a wound. They're like dusk after day. Not gone, just softer. And though we think of carbon dioxide as waste, your body treats it with care. It's buffered, carried, protected, and when it reaches the lungs again, it's released just as gently as oxygen once arrived. The breath you exhale contains this story, exhaled into the world, a soft return of what was once yours. There's something beautifully circular about it. Inhale. Oxygen enters, full of potential. Exhale. Carbon dioxide leaves, full of memory. And between the two, a life is lived. This returning blood, often called blue because of its darker hue, still pulses with meaning. It still flows in rhythm with your heartbeat. It's not lesser. It's simply on the other side of the story. Even now, your veins are hard at work. Whether you're walking or resting, talking or dreaming, they are gathering, guiding, returning. Your body, always cycling, always carrying breath forward and backward, always cradling both energy and a release. So next time you lie still and feel the hush of your own pulse, remember this. There is movement in the stillness. There is return in the quiet. Your veins are not empty. They are full of what was, ready to become what's next. Take a breath. Let it out slowly. That single breath, simple, soft, perhaps barely noticed, set in motion an entire journey inside you. Oxygen entered through your nose, slipped into your lungs, crossed into your blood, and was carried by red blood cells to your cells, your organs, your thoughts. And now, carbon dioxide is on its way out, carried gently back along quieter roads, preparing to leave with your next exhale. All of that. It happens in about 60 seconds. In one quiet minute, your blood completes a full loop through your entire circulatory system. Your heart, small enough to fit in the palm of your hand, pumps around 5 litres of blood per minute. That means your entire blood volume, every drop, is refreshed about once every 60 seconds. That's one full oxygen cycle, every minute of your life, and you don't have to lift a finger. It's humbling, really. This soft machine of chambers and valves, vessels and cells has been running since before you took your first breath. It runs while you sleep. It runs while you dream. It runs when you laugh, when you cry, when you pause and stare out the window. It never asks for recognition. It simply keeps time. Let's look again at what happens in that single minute. First, oxygen-rich blood leaves the lungs, entering the left side of the heart. The left ventricle contracts, sending this blood out through the aorta and into the arteries. It travels quickly, pushed by pressure and helped along by the rhythmic squeeze of the heart. Some goes up to your brain, some out to your arms, some down to your stomach, your liver, your legs, your toes, everywhere. As it moves, the vessels branch, arteries into arterioles, arterioles into capillaries. Here the blood slows. Gently, so only red blood cells release their oxygen into the tissues, where mitochondria wait to use it. At the same time, carbon dioxide diffuses into the blood, ready to be returned. Then begins the return. Veins gather this oxygen-poor blood, guiding it back towards the heart. Through the great veins, superior and inferior vena cava, it re-enters the right side, and with the next beat, it's pumped into the lungs again. There, carbon dioxide is released. and fresh oxygen binds to hemoglobin. The loop begins again. In the time it's taken you to listen to this paragraph, the loop may have completed once, maybe twice. That's how elegantly the system works. You might imagine this as a single river flowing in a loop, but it's more like millions of tiny rivers, all coordinated, all flowing toward the same goal. The scale is vast, yet the operation is seamless. At rest, your heart beats around 60 to 80 times per minute. Depending on your body, your mood, your age, each beat moves the loop forward. And when you move, walk, climb stairs, laugh, stretch, your heart speeds up, adjusting automatically. It doesn't need to ask you. It listens to your muscles, your breath, your body's needs. Then it responds quietly. There's also a hidden intelligence in the blood itself. The hemoglobin in red blood cells doesn't just pick up oxygen randomly, it adjusts based on your needs. In active tissue, where acidity rises and heat increases, it releases oxygen more readily. In less active areas, it holds on a little longer. The system doesn't just deliver, it prioritizes, it adapts, it thinks in its own quiet chemical way. Even your lungs adjust moment to moment. If one side of your body is compressed, the other side compensates. If you're lying down, gravity shifts blood flow in your lungs, and your body reroutes. It's like a city that constantly updates its traffic lights, always trying to ease congestion and keep everything flowing. And none of this needs your attention. The breath you're taking right now, it's completing the loop in and out over and over. Your cells never pause their need for oxygen and your heart never stops delivering. It's a partnership that sustains your life in every moment, even the quiet ones. Especially the quiet ones. Even now, perhaps as you begin to feel your eyes grow heavier, your thoughts slower, you're still breathing. Your heart is still beating. Oxygen is still arriving cell by cell without urgency, without noise. And that's the beauty of it, that something so essential can be so peaceful, not rushed, not forced, just a loop, a rhythm, a quiet promise. Every 60 seconds your blood makes the journey, and every time oxygen is there, waiting, ready, yours. At first glance, red blood cells seem simple. Round, soft, without a nucleus or any visible machinery. Just pale discs floating quietly through your bloodstream. But inside, something remarkable is happening. Inside each of these silent travellers is a molecule that performs a delicate, responsive dance every moment of your life. Hemoglobin. It's the molecule that makes red blood cells red. But more than that, it's the molecule that carries your oxygen one by one, gently, precisely to where it's needed. And the way it does this isn't rigid or mechanical. It's graceful, like a dancer adjusting to the tempo of the room. Each hemoglobin molecule is made up of 4 subunits. Think of them like 4 arms, each capable of holding one oxygen molecule, but they don't all reach out at the same time. No, hemoglobin is far more refined than that. When the first oxygen molecule binds, hemoglobin subtly changes shape. This tiny shift makes it easier for the second molecule to bind, and then the third, and then the fourth. It's called cooperative binding, and it's one of the quiet wonders of your biology. It's as if hemoglobin starts the dance cautiously, takes a step, then grows more confident with each move. But what's equally important is how hemoglobin lets go. Because oxygen isn't meant to stay bound forever. It needs to be released, and hemoglobin knows exactly when. This balance between holding and letting go is captured in something called the oxygen dissociation curve. Imagine a smooth S-shaped line. On one end, it shows how easily hemoglobin picks up oxygen when levels are high, like in the lungs. On the other end, it shows how hemoglobin begins to release oxygen when levels drop, like in your muscles or organs. But here's where the dance gets even more beautiful. This curve isn't fixed, it shifts. In warmer conditions, in tissues working hard, in areas with more carbon dioxide or lower pH, hemoglobin lets go of oxygen more easily. It adapts. This phenomenon is called the Bohr effect, and it means your blood is always listening, always adjusting. delivering oxygen where it's needed most, not just where it happens to be. Picture a courier who doesn't just follow a map, but senses urgency, lingering longer, at doors where the lights are on, where the windows are open, where someone waits. This shifting curve is what allows your body to perform under changing conditions. When you exercise, your muscles become warmer, more acidic, more active. The curve shifts to the right. Oxygen's released more readily. When you're at rest, it shifts back. You don't need to tell it to. It just happens. Even altitude changes the curve. High above sea level, the air is thinner. Oxygen molecules are fewer. Hemoglobin must hold on tighter, bind more readily even at lower pressures. And over time, your body adjusts. It produces more red blood cells. It changes how hemoglobin behaves. It shifts the curve again. This is why climbers take days to acclimatise. Why Sherpas, born in the thin air of Himalayan villages, can carry heavy loads where others struggle to breathe. Their bodies have adapted. Their hemoglobin dances to a different rhythm. Even conditions like anemia, where there are fewer red blood cells, bring about adaptations. The body tries to compensate, sometimes by increasing heart rate, sometimes by adjusting breathing, sometimes by tweaking the affinity of hemoglobin itself. It's not a perfect system, but it's a deeply responsive one. All of this is happening in the space of seconds. As red blood cells leave the lungs, they bind oxygen efficiently. As they reach tissues that are warmer, more acidic and lower in oxygen, they release it. Not in all or nothing bursts, but molecule by molecule depending on what's needed. There is no panic, no waste, just an elegant give and take, and this dance continues throughout your life. Right now, as you sit or lie here listening, every hemoglobin molecule in your body is deciding softly, continuously, whether to hold on or let go, whether to embrace or release, whether to carry or to deliver. It's not often we imagine chemistry as sensitive, but this is sensitivity at a molecular scale. And so the next time you take a deep breath, know that something beautiful happens just after. Hemoglobin reaches out, binds what you've taken in, and then, as your body asks, begins its careful release, a quiet rhythm, a molecular waltz, a dance as old as life itself. Let's follow the oxygen molecule further still. It's been drawn from the air, slipped into your lungs, crossed the alveolar membrane, nestled into a red blood cell, and been carried through the winding rivers of your circulation. Along the way, it's been held by hemoglobin with just the right firmness, secure but not possessive. And now it has arrived, at the edge of a cell, but not just any part of the cell. The oxygen has a very specific destination, a small oblong structure known as the mitochondrion. If you think of your cell as a little cottage in the woods, walls of membrane, pantry of nutrients, doors to the outside, the mitochondrion is the glowing hearth in the centre, the fireplace that turns raw materials into warmth, the place where fuel becomes life. Oxygen doesn't arrive alone. It comes with glucose, sugar derived from the food you've eaten, digested, and delivered. Together, oxygen and glucose enter the metabolic story known as cellular respiration. This story unfolds in three main acts. The first is glycolysis, which happens outside the mitochondrion, in the cell's cytoplasm. Here, one molecule of glucose is broken into two smaller units, called pyruvate. It's a bit like chopping firewood into smaller pieces. This process yields a small amount of energy, just 2 ATP molecules, but it prepares the glucose for what's to come. Next comes the Krebs cycle, sometimes called the citric acid cycle. This takes place inside the mitochondrion itself. Pyruvate is further broken down, and in the process, high-energy electrons are harvested. You can imagine this step like setting those firewood pieces into the hearth and arranging them carefully, each log positioned so it will burn just right. The final and most important step is the electron transport chain. Here's where oxygen steps in. Those high-energy electrons, carried by special molecules, are passed along a series of proteins embedded in the inner mitochondrial membrane. With each handoff, a bit of energy is released, like a spark from flint. This energy is used to pump protons across the membrane, building a gradient, a difference, a tension, like water behind a dam. Then the final move. Oxygen waits at the very end of this chain. It accepts the spent electrons, combines with protons and forms water. In that single moment, oxygen makes it all possible. Without it, the entire chain would back up. The electrons would have nowhere to go, the dam would collapse, energy production would stall. Oxygen is not the star of the show, but it is the final note in the melody, the one that makes the whole song feel complete. And with this elegant cascade, the cell produces around 36 ATP molecules from a single glucose molecule. Far more than glycolysis alone could offer. It's the difference between a candle and a roaring fire. This energy, ATP, isn't stored in great reserves. It's used immediately to move muscles, to send signals, to grow, repair, maintain and think. Without oxygen, your cells can still make a bit of ATP through anaerobic respiration, but it's a shadow of the full process. It yields just 2 ATP per glucose and produces lactic acid as a byproduct. That's the burn you feel during intense exercise when your muscles outpace your oxygen supply. And even that system, that backup mode, is only temporary. Eventually oxygen must return because the true breath of life isn't just in your lungs. It's in your mitochondria. In that final moment where oxygen catches an electron and says, "I've got it, I'll take it from here." And then, water. Yes, water. Every day you make a small amount of internal water, not from drinking but from metabolism. Oxygen turned to water inside you. A gentle alchemy. A transformation so quiet you'd never know it was happening. But it is. Even now, as you lie still, as you read, as your heart beats gently in the background, oxygen is entering your cells, accepting electrons, powering the fire within. It's easy to think of breathing as something that happens in your chest, but in truth you breathe with your whole body. Your cells are breathing too, every second, every breath. Most of the time, oxygen's journey through your body is quiet, seamless, almost poetic, but not always. Sometimes the dance stumbles, the delivery falters, the whisper of breath grows strained. And when it does, your body responds, not with panic, but with signals, symptoms, subtle shifts, gentle reminders that something isn't quite right. One of the most familiar disruptions is hypoxia, a condition where tissues don't receive enough oxygen. It can happen in a dozen different ways. Maybe the lungs can't pull in enough air. Maybe the heart isn't pumping efficiently. Maybe the blood isn't carrying its precious cargo well. Whatever the cause, the result is the same. Cells grow tired, movement slows, thoughts blur. The quiet rhythm of oxygen delivery begins to lag behind the body's needs. Sometimes it's not a lack of oxygen itself, but a shortage of the carriers. This is anemia, a condition where there aren't enough red blood cells, or where the cells don't contain enough hemoglobin. The oxygen may be waiting at the alveoli ready to be picked up, but if there aren't enough couriers, the delivery doesn't happen. Anemia can arise from many things: blood loss, nutritional deficiencies, chronic diseases. Often it creeps in gradually. You may feel fatigue, shortness of breath, a heaviness even when doing simple tasks. It's as if the body is still trying to carry the same weight, but with fewer hands. And when oxygen delivery is deeply impaired, a strange colour begins to appear. Cyanosis, a bluish tint to the lips, fingers, or skin. It's the body's visual language for oxygen's low here. The blue isn't literal, it's the colour of deoxygenated hemoglobin seen through layers of tissue. It's the colour of blood waiting, needing, not quite receiving. There are also invisible disruptions, ones that come not from within, but from the air around you. Smoking, for example, damages the lungs over time, destroying alveolar, thickening the airways, and impairing the cilia that help keep lungs clear. The architecture of breath becomes scarred. The walls thin, the surface area for oxygen exchange shrinks. With fewer alveoli, the oxygen that enters can't always find its way into the blood. The breath becomes shallower, less effective. It's like trying to water a garden with a cracked hose. And then there's carbon monoxide, a gas with no smell, no colour, no warning. It binds to hemoglobin more tightly than oxygen does, 200 times more tightly in fact. Once attached, it won't let go. It pushes oxygen out of its seat and rides along silently, preventing proper oxygen delivery. Even small exposures can make you feel dizzy, confused, heavy. With more exposure, the results become dangerous, because the cells are starved even when the lungs are full. Sometimes the challenge isn't damage or pollution. Sometimes it's simply altitude. At high elevations, like the peaks of the Andes or Himalayas, the air contains just as much oxygen by percentage, but the pressure is lower. That means fewer oxygen molecules enter your lungs with each breath. The body notices quickly. You breathe faster. Your heart beats harder. You may feel lightheaded, as if your thoughts are rising too fast for your body to follow. This is altitude sickness, the body's first protest. But given time, the body adapts. It begins to produce more erythropoietin, a hormone that stimulates red blood cell production. Your blood becomes richer in couriers. The hemoglobin curve shifts to make it easier to bind oxygen. Capillaries may grow, increasing surface area for exchange. This is why Sherpas, who live at high altitudes year-round, can ascend mountains where others struggle to walk. Their bodies have learned to use oxygen more efficiently. Their blood has a different rhythm. Even among climbers who visit these heights only occasionally, the body tries to learn, tries to adjust, tries to breathe, even when the air grows thin. But not all damage is reversible. Some lung conditions, like emphysema or pulmonary fibrosis, change the structure of the lungs permanently. The walls between alveoli break down or stiffen. Gas exchange becomes harder. The breath grows laboured. And still, the body finds ways to cope. It reroutes blood flow to better ventilated areas of the lung. It increases breathing rate. It sends signals to slow the body, conserve energy, rest. Even in suffering, the system remains elegant. And sometimes the remedy is simple. A deep breath, clean air, rest, time. The same oxygen that fails can also heal. It nourishes inflamed tissues, calms racing hearts, clears headaches and lightheadedness. It returns, and with it, strength returns too. Because oxygen is not only what fuels you, it's what brings you back. You may not notice it, but your body is always listening to the air, to the blood, to the very molecules that flow through you. Every breath you take is part of a conversation, a quiet moment-to-moment dialogue between your cells and your brain, not in words but in chemistry, not with language, but with levels of oxygen, carbon dioxide and pH. Let's follow that whisper upstream. Somewhere along the arteries that supply your head and brain, nestled near where your carotid arteries split in your neck, are tiny structures called the carotid bodies. They're small, just a few millimeters, but astonishingly sensitive. Alongside them, near the heart's arch, are the aortic bodies. Together these serve as sentinels, always tasting your blood. Always asking the question, is there enough oxygen? These sensors don't just measure oxygen though. They also detect carbon dioxide levels and acidity, since too much CO2 lowers pH and changes the body's internal balance. In truth, your brain is more sensitive to rising CO2 than to falling oxygen, like a fire alarm that detects smoke before it feels the heat. When these chemical watchers notice a shift, when CO2 rises or O2 falls, they send electrical signals to the medulla oblongata, a region deep in the brainstem. This part of your brain is ancient, shared across species, built to control things you never need to think about: heartbeat, digestion, and most importantly, breathing. And once the message arrives, your breathing adjusts, without asking permission, without requiring effort. Your respiratory rate might speed up, your breaths might deepen, and oxygen delivery improves. If you're asleep, you'll breathe faster without waking. If you're climbing stairs or sprinting or laughing too hard, your body adjusts in real time, keeping up with your needs. This is the beauty of the autonomic nervous system, the part of your body that manages essential functions behind the scenes. You don't have to remember to breathe, your body never forgets. But here's the fascinating twist. breathing is also voluntary. Unlike your heartbeat, which stays out of your control, your breath can be guided. You can hold it, slow it, shape it. You can sigh, gasp, laugh. You can take a deep breath before a speech, a test, a kiss. And when you do, your brain listens. A long, slow exhale tells the parasympathetic nervous system to take the lead, to calm, to slow, to soften. Your heart rate decreases, your muscles loosen, your thoughts drift just a little more gently. That's why we sigh when we're overwhelmed, why we yawn when we're tired, why we take a deep breath before stepping into cold water or speaking in front of a crowd. Each of these is a signal not just to the lungs, but to the brain, the heart, the whole self. The yawn, for example, isn't just about boredom or sleepiness. Some scientists believe it's your brain's way of cooling down, bringing in a rush of air to reset temperature, circulation and focus. It's like opening a window in a stuffy room. And sighing? It's more than emotional punctuation. Physiologically, it's a built-in lung reset. Your body sighs regularly every few minutes, whether you're aware or not. A sigh inflates tiny collapsed alveoli, keeping your lungs open and elastic. It's maintenance disguised as expression. In this way, breathing becomes a kind of bridge. A thread between the voluntary and involuntary, between mind and body, between choice and instinct. That's why practices like meditation and breathwork feel so powerful. When you guide your breath, you gently take the reins of systems usually out of reach. You send ripples through your nervous system, down into your chest, your gut, your limbs, and it all starts with the same air you've always breathed, just slower, just deeper. It's not magic, it's oxygen, responding to chemistry, responding to thought. Even now, as you read, or perhaps drift, a signal is flowing through your bloodstream. The carotid body is sensing, the medulla is responding, and your breath is adjusting. Quietly. Exactly as needed. You don't need to command it, you're already part of it. Breathing in balance, breathing in rhythm, breathing in you. We often think of the oxygen as something purely functional, a fuel for our cells, a driver of breath, the invisible gas that keeps us alive. But oxygen plays another role, one that moves beyond chemistry and into sensation. It weaves its way through not just your bloodstream, but your sense of presence. Like a thread, it links body to mind, moment to moment, breath to being. You've likely felt it before without knowing. After a deep inhale, there's a subtle pause, a quiet suspension of time. Then comes the long, measured exhale, and with it, a softening. Shoulders drop, the heart slows, the noise in the mind recedes just a little. That feeling, that shift into calm is not imagined. It's the physiological imprint of oxygen doing more than simply fueling cells. Each breath you take speaks directly to your nervous system. When you breathe slowly, with depth and ease, your body activates the parasympathetic nervous system, the network responsible for rest, digestion, healing and calm. Heart rate decreases, muscles unclench. The sense of urgency softens into quiet. These aren't abstract effects. They are measurable, real, and remarkably accessible. Through breath, we touch the edges of our physiology, and breath responds in kind. Scientific studies have shown that intentional breathing can reduce cortisol levels, ease anxiety, and shift the rhythm of brainwaves towards more relaxed states. Your body listens to how you breathe. It interprets short, rapid breathing as stress, tension, alertness. It understands long exhales as a signal to let go. This is why a sigh feels like release, not just emotionally, but biologically. Every few minutes, even when you're unaware, your body initiates a spontaneous sigh to reinflate collapsed alveoli and keep your lungs elastic. The feeling of relief that often follows is a result of both physiology and perception aligning. Similarly, a yawn might stretch your jaw and cool your brain, acting as a kind of system refresh. These reflexes, sighs, yawns, the first deep breath after holding still, aren't just quirks. They are signals from your body to regulate, to reset, to return to balance. And they remind us that breathing is one of the rare bodily functions that lives at the intersection of the automatic and the voluntary. You don't have to think about breathing, your brainstem will take care of that. But you can think about it. You can choose to breathe slowly, to hold for a moment, to lengthen the exhale. And with that choice, you gently shift your internal landscape. You reach into the autonomic system, not by force, but by rhythm. This is the principle behind meditation, mindfulness, and breath work. These practices don't change the outside world, but they profoundly shape how we meet it. By anchoring attention in the breath, we find a kind of stillness, a return to the moment at hand. Thoughts may still come and go, but they pass like clouds across a wider, quieter sky. In that stillness, oxygen becomes more than a gas. It becomes a companion, not something you must chase or manage, but something that moves with you. It's the hush behind your words, the steady rhythm beneath your thoughts, the constant presence that reminds you you are here and you are alive. Ancient practices have long recognized this truth. In yoga, pranayama teaches the conscious expansion of breath. In Zen, the breath is often counted, noticed, accepted without judgment. In countless spiritual traditions, a breath precedes the sacred. Before prayer, before intention, before action. Even an archer drawing a bow takes one quiet inhale before release, steadying not just the hand but the whole self. Emotion too is tied to breath. Anxiety often shortens it. Grief sometimes holds it still. Calm allows it to deepen. And here lies the quiet power. You can shift your emotional state by shifting your breathing pattern. It's not about pretending to be calm. It's about breathing in a way that allows calm to return. When your day has been full, your mind scattered, your body tense, you don't need to do much. Sit down, notice the breath as it is, then gently lengthen it. Count a slow inhale, hold it for a second, let the exhale unfold like a ribbon unwinding. Do it again and again. You don't have to force the calm, just breathe in a way that invites it. This is the invisible thread. Oxygen moving not just through your body, but through your awareness. Binding physiology and emotion, tension and release, presence and peace. Even now you are breathing. Even now oxygen is arriving silently into your cells. Even now your body is listening. And when you listen to, when you meet your breath where it is, you return to something fundamental, something quiet and enduring. You return to yourself. There's a quiet kind of devotion happening inside you. No applause, no names remembered, but if you could zoom in, past skin, past tissue, past vessels, you'd find it. The ceaseless work of your red blood cells flowing silently, faithfully, with every beat of your heart. Let's meet them at the beginning. They are born not in the lungs or the heart or the blood itself, but deep inside your bone marrow, the soft, spongy tissue, tucked within your larger bones. In your ribs, pelvis, vertebrae and sternum, millions of new red blood cells are created every second. Each begins life as a stem cell, capable of becoming many types of blood cells. Guided by chemical signals and growth factors, some of these cells begin a specific transformation, the path to becoming oxygen couriers. During their development, these young red blood cells, called erythroblasts, are like apprentices preparing for a singular role. They grow, divide, and then, in a final act of refinement, they eject their nucleus. That's a rare move in the world of cells. Most cells keep their nucleus as a command centre, a repository of DNA, a symbol of identity. But red blood cells give theirs up in favour of something more important: space. Without a nucleus, they can carry more hemoglobin, the protein that binds and transports oxygen. Without a nucleus, they become more flexible, able to bend and squeeze through capillaries barely wider than the cell itself. It's a sacrifice, but a purposeful one. They trade selfhood for service. Once matured, they take on their iconic shape, a biconcave disc, round, indented on both sides. It's an elegant design. The curve increases surface area, allowing oxygen to diffuse more quickly. The flexibility lets them tumble and twist through your narrowest vessels like coins through winding chutes. and so they enter the bloodstream. From marrow to movement, they begin their quiet task, picking up oxygen in the lungs, releasing it in tissues, collecting carbon dioxide, returning again. They don't make decisions or change course, they simply respond to gradients, to signals, to needs. They circulate in vast numbers, 20 to 30 trillion in your body at any time. Each one makes the full loop, from lungs to tissues and back, roughly once a minute. In a day, a single red blood cell will complete that loop more than 1,000 times. And they do all this without a nucleus, without mitochondria, without any organelles, no instructions to update, no energy to spare. Their fuel comes from glycolysis, a basic anaerobic process. They are, in many ways, living machines, streamlined for one function, to carry breath. But they are not immortal. A typical red blood cell lives for about 20 days. That's 4 months of ceaseless travel, billions of miles in microscopic terms. Over time, their membranes wear thin, their flexibility wanes, they grow stiff and fragile, and their journey begins to end. And when it does, your body doesn't. Panic. It notices. In the spleen, often called the graveyard of red blood cells, aged and damaged cells are gently filtered out of circulation. The spleen's narrow channels and immune sentinels inspect each passing cell. Those that no longer bend or flow smoothly are removed, engulfed by macrophages, and quietly dismantled. But even in death, red blood cells give back. Their components are recycled. The iron from their hemoglobin is salvaged and sent to the liver or marrow to be used again. The globin proteins are broken down into amino acids. The heme group is converted into bilirubin, which gives colour to bile, and later to your skin and eyes in the subtle tints of health or imbalance. Nothing is wasted, even their endings are purposeful. It's humbling, really. These cells live without identity. They carry no instructions once mature, they cannot repair themselves, they cannot reproduce, and yet they perform one of the most vital functions in your body. They carry oxygen, the breath of life, from moment to moment, not loudly, not dramatically, just endlessly. And you don't notice them. You rarely feel them working, you rarely think about them aging, or dying, or being born anew, but they are. Right now, millions of red blood cells are being created in your bones. Right now, millions more are reaching the end of their path, quietly retired in the spleen or liver. And right now, the vast majority are in motion, flowing through capillaries in your fingers, your eyes, your lungs, your brain. Each one a silent traveller, each one a quiet thread in the tapestry of your breath. Their story is not filled with complexity or drama. It's a story of dedication, of flow, of cycles completed in humble rhythm. And if you listen, if you slow down enough to feel the pulse in your wrist or the rise of your chest, you might catch a glimpse of them. Not directly, not visibly, but in the feeling of oxygen arriving, in the warmth of your skin, in the ease of your breath. They are there, always moving, always serving, always returning. Take a breath, feel the air enter you light and easy, a blend of gases filtered by leaves and time. Oxygen, so abundant now, seems like an obvious part of life. But it wasn't always here, and it certainly wasn't always welcome. To understand the story of oxygen in your body, we have to go back, far beyond your bones or blood, beyond mammals and dinosaurs, even beyond the earliest fish. We need to return to a world that had never known breath. Early Earth was a quiet, alien place. The atmosphere was thick with gases, but oxygen was not one of them. Life began not in air, but in water and stone, deep-sea hydrothermal vents, where heat and the minerals created chemistry's first whispers of biology. The earliest life forms, anaerobic microbes, thrived in oxygen-free environments. They had no lungs, no need for breath, and no concept of this reactive gas that would one day change everything. Then came a quiet revolution. Around 2.5 billion years ago, tiny organisms known as cyanobacteria began to perform a new trick: photosynthesis. Using sunlight, water, and carbon dioxide, they produced energy and, as a byproduct, released oxygen into the oceans and atmosphere. Slowly, imperceptibly, the world began to change. At first, oxygen wasn't a gift, it was a toxin. For many anaerobic life forms, it was dangerous, corrosive, even deadly. It broke molecular bonds and damaged cells. Entire ecosystems vanished. But evolution has always responded. Some organisms perished. Others adapted. A few learned to use oxygen's reactive nature to their advantage. That shift led to one of the most profound transitions in the history of life: the rise of aerobic metabolism. Unlike anaerobic pathways, which yield only a small amount of energy, aerobic respiration with oxygen unlocks the full potential of food molecules. It's cleaner, more efficient, and powerful enough to support complex, energy-hungry life. Muscles, nerves, movement, thought. But oxygen posed a logistical problem. It needed to be transported and managed. Free oxygen in the environment wasn't enough. It had to reach deep tissues far from the surface. It had to be bound, carried, and delivered with care. And so over time, life crafted a molecule to meet the need. That molecule was hemoglobin. Early versions of oxygen-binding proteins likely evolved in primitive aquatic animals. These proteins needed to hold onto oxygen in water, where concentrations are much lower than in air. The result was a class of molecules, globins, with the remarkable ability to bind oxygen at just the right strength, firm enough to hold it, loose enough to let it go. Hemoglobin became one of the masterpieces of molecular evolution. In humans and many other animals, hemoglobin is tucked inside red blood cells. It contains iron atoms at its core, each capable of binding one oxygen molecule. These iron atoms give blood its red colour when oxygenated, and its darker hue when not. The colour changed is not just poetic, it's chemical. Visible evidence of a bond formed or broken. The structure of hemoglobin has remained astonishingly conserved across species and time. But nature didn't stop there. Evolution created variations on the theme. Myoglobin, found in muscles, binds oxygen even more tightly, holding onto it for use during periods of intense activity. Fetal hemoglobin in unborn humans has an even higher affinity for oxygen than adult hemoglobin, allowing the fetus to draw oxygen from the mother's blood across the placenta. These are quiet optimizations tuned across millions of years, and so, from poison to partner, oxygen became part of the story of life. It shaped cells, tissues, and entire ecosystems. It changed the atmosphere. It allowed for fire, for flight, for breath. And it made complex, multicellular life not just possible, but sustainable. Even now, the echoes of that transformation remain inside you. Every time you inhale, you're participating in a story that began before air was breathable. Every hemoglobin molecule in your red blood cells is the product of a billion-year negotiation between energy and safety, between function and fragility. And your ability to sit, to move, to think, to rest, depends on that balance. It's easy to forget. Oxygen seems so mundane, so constant. But it wasn't always here, and you weren't always meant to breathe it. That you do now, that your body is built to carry and deliver it cell by cell, is not an accident. It is an inheritance. And with each breath you carry a piece of that ancient transformation within you. You breathe with lungs, soft elastic organs that draw air into the folds of your chest and exhale it again, in rhythm with your thoughts and heartbeat. It's a simple act, familiar and constant. But across the living world, oxygen is gathered in many different ways, some strange, some elegant, all shaped by the quiet requirements of life. Let's drift outward now, away from the human body, and into the many forms oxygen's journey can take. Begin in the water. Fish, ancient and enduring, do not breathe air the way we do. Instead, they pull water through their mouths and across delicate filaments in their gills, thin, richly vascularized structures designed to extract oxygen from the fluid that surrounds them. Water passes in one direction, blood in the other, a process called countercurrent exchange, which allows fish to absorb the maximum amount of dissolved oxygen, even in water where it is scarce. It's not fast, it's not loud, but it is effective. A trout hovering in a stream, barely moving, breathes constantly, not through expansion of the chest, but by letting water slide over its gills, exchanging gases without ever needing to surface. This is breath without air, a life lived submerged, yet always linked to oxygen's presence. Now lift your gaze to land. Insects, small and ancient architects of the earth, breathe through a system far removed from our own. They don't have lungs or blood vessels that carry oxygen to cells. Instead, they rely on a network of tiny tubes called trachea, which branch throughout their bodies and open to the outside through small holes called spiracles. Air travels directly through these tubes to reach every cell. No hemoglobin, no red blood cells, no intermediary. It's a system best suited for small bodies and short distances, but it works with quiet precision. A resting butterfly, wings folded in the sun, draws air inward, not with a breath, but with a soft pulse of its abdomen, an almost imperceptible gesture, like a whisper through lace. Then to the sky. Birds, whose demands for oxygen are immense due to the energy required for flight, have developed one of the most efficient respiratory systems in the animal kingdom. Unlike humans, who breathe in and out through the same path, birds move air in one direction through their lungs, ensuring a constant flow of fresh oxygen. They use air sacs, extra pockets throughout their bodies, that act like bellows, pushing and pulling air in a continuous circuit. When a bird flies, oxygen delivery doesn't pause with each breath. It flows on, uninterrupted, like wind through a narrow canyon. This unidirectional flow allows birds to fly at altitudes where oxygen is thin, soaring over mountaintops, carried by wings and breath that never quite stop. And now, plunged deep, whales, seals, and diving mammals face a different challenge altogether. Their bodies must operate without fresh oxygen for extended periods, sometimes over a mere hour, while submerged in dark, cold depths. To adapt, they've developed extraordinary strategies. Before a dive, these animals inhale deeply, filling not just their lungs, but saturating their muscles and blood with oxygen. They have far more myoglobin, a cousin of hemoglobin that stores oxygen in muscle tissue, than we do. This protein gives their flesh a deep red colour and the ability to carry on in the absence of breath. During dives, they slow their heart rate, redirect blood away from non-essential organs, and conserve energy. Their muscles operate in low oxygen conditions, even tolerating lactic acid buildup until they surface again. A sperm whale plunging a mile beneath the ocean doesn't breathe for over an hour. Yet every cell in its body knows how to stretch its oxygen supply, how to endure without panic. Even frogs, in still ponds and leaf litter, can breathe through their skin. Their moist, permeable outer layer allows for gas exchange directly with the environment, especially when submerged or dormant. It's a passive kind of breath, a patience more than emotion. Each of these strategies is different. Gills, tracheae, lungs, air sacs and spiracles, molecules and muscle memory, but they all serve the same ancient task, to gather oxygen and deliver it to the waiting cells. The methods vary. But the need is universal. Even in the strangest of environments, oxygen deserts, cold oceans, thin mountain air, life finds a way to reach for breath. And when we look at these creatures, not just as animals, but as fellow participants in the oxygen cycle, we see something deeper. Breath is not just survival, it is adaptation, expression, a reflection of what each organism has faced and overcome. You breathe one way, a beetle breathes another. A penguin, diving beneath Antarctic ice, holds breath with more grace than we can imagine. But the purpose is shared. The quiet contract of life: find the oxygen, Carry it in and let it go when its work is done. This is what links you to everything that crawls, swims, climbs, or flies. Not a shared language, not a shared form, but a shared breath. Take a breath and let it out slowly. That breath, so ordinary, so quiet, carries a story that stretches across the ages, because the oxygen you just inhaled is not new. It isn't made fresh for you each morning. It wasn't waiting in some reserve tank untouched by time. It's ancient, well-travelled, part of a long, unbroken chain that links you to everything that has ever lived. The molecules in that breath may once have drifted through the lungs of a dinosaur, swirled through the leaves of a fern in a prehistoric forest, or lingered in the gills of a trilobite beneath a silent sea. The atoms of your current breath might have passed through a bonfire in a Neolithic village, or circled inside the bloodstream of a mammoth sheltering from the cold. This isn't poetic speculation, it's chemistry. The number of oxygen molecules in Earth's atmosphere is staggeringly large, yet finite. And the process of respiration, taking in oxygen, using it, releasing it as carbon dioxide, is a cycle shared by all aerobic life. That means the oxygen you're breathing now has been recycled over and over again for billions of years. When an organism breathes out, oxygen becomes carbon dioxide. Plants take it in through photosynthesis, split it apart and release fresh oxygen back into the air. That oxygen gets breathed in again, by birds, by foxes, by frogs, by you. In this way, oxygen becomes part of an invisible communion. Across time, across space, across species, it doesn't carry memory in the way a photograph does, but in a deeper sense, it does carry presence. The very same atoms that powered the muscles of a saber-toothed cat may now be feeding your mitochondria. The breath once exhaled by an ancient ancestor might now be resting in your lungs, awaiting its own quiet journey through your bloodstream. And those molecules will continue on. After they leave you, they will drift, shift, mix with the air around you. Some will be drawn into a tree, bound into sugar by a leaf, released again in sunlight. Some may spiral upward into the high atmosphere. Some may be inhaled by a fox curled in the underbrush, or a baby taking its first breath just a few miles from here. In this way, you're never truly separate from the world. You breathe it in, you become it, and then you give it back. The idea that you may be breathing the atoms of a dinosaur's breath is not just a lovely thought. It's a reflection of molecular truth. Each oxygen atom is virtually indestructible under ordinary conditions. What once flowed through the ancient lungs now flows through yours. And what passes through you will one day move through others. That's the quiet legacy of breath. Not a monument carved in stone, but a presence passed gently from life to life. Unspoken and continuous. Even within your own body. Oxygen carries this sense of passage. It arrives, not to stay, but to serve. It binds, it delivers, it transforms. Then it lets go. No oxygen. Molecule lingers forever in one place. It's always in motion, arriving, becoming, departing. Just like you, there's something humbling in that. Something comforting too. Because it means that in every breath you are part of something larger, older than you, bigger than cells and vessels and science. You are part of the breath of Earth, of all who came before, of all who will come after. In the quiet moment between your inhale and your exhale, you hold a piece of that endless story, not just metaphorically, molecularly. So breathe again, gently, with awareness, with reverence, because the breath, this simple, unnoticed action, is a bridge. Between you and the past, between you and the planet, between you and everything that breathes. And when you exhale, you're not losing it, you're giving it back. All day long your breath has been there, quiet, constant, never asking for attention. It has risen with you, walked beside you, held you steady through thoughts and movement, or even says through stillness and surprise. And now, as the world grows softer and your body begins to slow, just breath remains. Still here, still offering, still carrying you. Each breath you take is a gentle cycle, a giving and a receiving. Oxygen enters with the inhale, travels quietly through lung and blood and cell, and then returns transformed, ready to be let go again with the exhale. It's not loud or urgent. It doesn't ask you to try, it simply happens. Over and over, a rhythm older than words, a presence beneath every task. In a way, your body has been keeping time all day, not with clocks or numbers, but with breath. The soft rise of your chest, the quiet fall, the pause between, like waves against the shore, returning without fail, even as the rest of you moved forward through the hours. And beneath that rhythm something remarkable, a system that carries on without praise, your lungs expanding and relaxing, your diaphragm contracting without fanfare, your red blood cells flowing silently through thousands of miles of vessels, delivering oxygen to your tissues with quiet precision. You don't have to manage them. You don't have to instruct. They simply do their work, faithfully and visibly, minute after minute. Even now, as you listen, your body is adjusting. Heartbeat slowing, breath deepening, muscles loosening one fibre at a time. The same oxygen that once sprinted through your bloodstream now begins to arrive in quieter places, in your fingertips, your toes, your eyelids. There's something comforting in that, something deeply kind, because your breath doesn't just fuel you, it soothes you, it reflects you, it mirrors what's needed, moment by moment. When your mind races, your breath quickens. When you pause, your breath finds stillness. When you feel safe, your breathing grows slower, softer, rounder at the edges. You don't have to explain, your body already knows. Even now, as your eyes grow heavier, your breath is listening. You might think of your body as a quiet machine, one designed not for noise or spectacle, but for peace, each part working in harmony, each breath like a note in a song that's been playing since the moment you were born. The breath that carried you through your first cry, the breath that steadied you during laughter, the breath that softened when you were held, when you were quiet, when you felt safe. It's all the same breath, and it holds you still. You don't need to do anything with it now, no control, no effort, just notice it if you like. Feel the air move in, feel it drift out. Maybe place a hand on your chest or your belly and notice the gentle movement there. That's you, that's your body caring for you without question. Let it continue, let it carry you. There's nothing you need to solve in this moment, nothing you need to achieve. You're already doing enough simply by breathing. Oxygen moves where it's needed. Muscles relax without asking. Cells slow their activity just a little, preparing for rest. You don't have to understand it all. You don't even need to remember it. Just know that it's happening. You are being held by breath, by rhythm, by something within you that has never forgotten how to care for you. So let it. Let your breath be soft. Let your body grow heavy. Let the thoughts quiet, not because they must disappear, but because they've been heard, and now they can rest too. This moment is enough. This breath is enough. You are enough. Some of the oxygen in your body was made in the heart of stars. Billions of years ago, long before Earth had an atmosphere or oceans or breath, massive suns lived and died in distant corners of the universe. In their final moments, they collapsed, exploded, scattered their contents into space. Among those contents was oxygen, one of the gifts forged in cosmic fire, hurled across light years, and eventually folded into planets, rocks, rivers, and you. That oxygen drifted for eons. It became part of the earth. It flowed through oceans, dissolved in rain, rested in stones, passed through ferns, was exhaled by fish, gathered in leaves. And now, here it is, in you, in your lungs, in your blood, in the soft space between thought and sleep. That same oxygen is in the trees outside your window, in the breath of the person you passed earlier today, in the air that moves gently through an open door, across a hill, between clouds. It doesn't belong to anyone, and yet it belongs to everyone. This breath too is shared. There is something sacred in that, something humbling and kind, because when you inhale, you take in more than gas. You take in memory, connection, a trace of everyone and everything that came before, and when you exhale, you give some of that back. A quiet offering, a moment returned. Your body knows this rhythm. Inhale, exhale, take, give, hold, release, not as commands, just as what is. And now, as your breath grows slower, as your body softens and your thoughts begin to float, you are still participating in that quiet rhythm. Not doing, but being. Not forcing, but allowing. Let this be a moment of ease. You've taken in so much today, so much breath, so much light and sound and motion, and now it's okay to let it settle, to let it all slow, to feel the simple miracle of existing, not as something to earn or perfect, but as something already complete. You're breathing. That is enough. The oxygen within you is still flowing gently from lungs to blood to cells, still feeding your body, still caring for the quiet places, your fingertips, your scalp, your toes, the parts of you that do not ask for attention but are always part of you. You may not notice it now. You don't need to. It is happening anyway. With every exhale, your body says, I am here, I am okay, and with every inhale, I am still part of everything. This is the gentle truth that oxygen teaches us. You are not separate. You are not alone. Even in stillness, you are connected to trees, to oceans, to breath, to stars. So if you are ready, let your breath carry you downward into sleep. Let the muscles around your eyes loosen. Let your jaw soften. Let your thoughts fall out of shape. There is nothing you need to hold on to now. If sleep comes, welcome it like mist on a quiet field, soft, slow, without edge. If it doesn't, that's okay too. Rest lives in stillness, not just in sleep. And you are resting already, simply by being here. This final breath of the day is not an end. It's a return to yourself, to rhythm, to quiet. Let it be soft, let it be slow, let it be enough. Thank you for spending this time here, for letting the story of oxygen become not just science, but sensation. Not just a fact, but a breath you feel in your chest as you lie in the dark, safe and still. And when you're ready, or even if you already are, sleep. The oxygen will still be there, breathing with you, holding you, carrying you into the hush,